Okay, in this video we're going to look at compound inequalities, and we can see that up here. And the key is the compound. And this is where we have a solution set that has a couple restrictions instead of this one like endpoint and an arrow that goes on forever in one direction. Either we have two sets of answers or we have a single set of answer. So let's take a look here at some math setup that does it, and I'll talk about an application and where we see that as well. So an AND is, for instance, where we have two pieces, this piece and this piece. So let's go ahead and graph this piece. X is bigger than -2. So we're going to have, -2 in a normal line, and it's bigger than, okay? And then over here we have X is less than or equal to 1. So it'll be a solid circle, and at 1 going this way. So the key is it has to be both. And means both, okay? And so if I said, okay, let's put both of those on the same graph. Well, if we have -2 here and 1 here, it has to be at the same time bigger than -2, but smaller than +1. So it's any value in between. So it could be 0, -1, -1.5, any value in between here. And notice it almost looks like a dumbbell where you have a line in between with two endpoints. We see this, and this is an AND statement. So for instance, like going to the movie theater, to pay full price, you have to be older than 12 years old, but under 64 for like senior citizens. An OR statement is one or the other, so we're going to say either. Okay, and this is actually the opposite thing. So here's 0. X is bigger than or equal to, so solid going this way. And we want X is less than -1, so -1's over here. So notice they don't overlap. So here we're going to have -1 and then 0. And this one goes to the right, and then this one goes to the left. Notice they do not overlap. So you're either in this solution set or this solution set. The keyword's there. So again, talking about price of movie theaters. To get a discounted ticket, you have to be less than 12, so that's like to the left, or older than 64. So obviously nobody's less than 12 and older than 64 at the same time, but you get the discount if you're in one or the other. Whereas if I said if you're older than 12 and less than 64, then you pay full price because you're in between. So an AND is, in between, and OR is, one either or, okay, one or the other. So let's take a look here. Here's some, translating from written statement. All real numbers that are greater than 2, okay, and less than. So the key here is and less than 3. Okay, so it has to be bigger than -2, but less than 3 at the same time. So this is an and statement because it's in between. Okay. All real numbers less than 0. Okay, so here's 0. Or greater than or equal to 2. On this way. So notice they repel each other, so this would be an OR statement. So that graph is always the same. So AND is always in between, and OR is always in opposite direction. So that's the key to this one here. All right, now when solving them, notice the expression is in between. So this is an AND statement. That's a great way to, so sometimes you can literally write the word, this and this. So, sometimes we'd see it like this, and it would say the word and you would write x plus 5 is less than 9. So you could do that. But a lot of times when they do an and they put it in between, they have it here. So it's just like what we did with regular inequalities, but there's two of them. So there's like almost like two equal signs. So the key is whatever we do to one region, we have to do it to the other. So to get x by itself, we need to subtract 5. Now if I do it in one zone, I have to do it in all 3 zones. So I'm going to do it like that. Okay, 2 minus 5 is -3. The 5's cancel. And then 9 minus 5 is here. So I asked the question, did I multiply or divide by a negative number? No. So I'm going to bring the signs down as they were. And being that x is in between, this is an and statement. X is bigger than -3, and x is smaller than 4. So I'm going to put on a number line, and put -3 over here, 4 over here, and no lines underneath, so open circles, and it's in between. Bigger than -3, but less than 4. Okay, let's take a look at the example here. So again, I'm going to draw my bars down here where my equal signs would be. I'm going to add 3, move the 3 to all sides. So we have negative 2 here, 5 here, and then negative x in the middle. Next, I'm going to divide by negative 1, all sides. So that becomes a positive 2, positive x, and a negative 5. Now the key is, did I multiply or divide by a negative number? Yes, I did, right there. So I need to switch the sign. So that becomes this way, and that becomes this way. So again, when I look at it, I'm looking at this statement right here. So we have a 2 and a negative 5. So let's just look at the 2 part right here. X is smaller than 2. Okay, so smaller than 2. And x, so let's look at this part. X is bigger than negative 5. So this way you can't follow the arrows because things get switched with the signs. X is bigger than negative 5 and equal to. So I guess both of these should be filled in. Sorry about that. So bigger than negative 5. So notice it's in between, everything in between. Okay. If you did not switch the signs, this graph would not make sense. And being that's an and statement, because it's in between, we know the graph has to end up being in between. So we can see the and in between here. Now let's talk about or statements. Now ors, you can't write as one statement. You literally have this equation or this equation. So it's almost like 2 problems in one, but you graph as a single answer. So put a note here, graph, one answer, or one, number line, but it has 2 parts. So here, I'm going to subtract 3. So we have 2x compared to 6 divided by 2. Notice I don't write the inequality every single time. And I looked, did I multiply or divide by a negative? No, I did not. Okay, I'll do this one in a different color. So we're going to add 6 to both sides. So 3x compared to 18 divided by 3. And x is compared to 6. And then did I multiply or divide by a negative number? No, I did not. Okay, so we have 2 different things here. So let's go ahead and draw in a number line. My values of 3 and 6, put those in order. Now let's go back. Let's look at this one right here. X is less than 3. Okay, so less than goes that way. And then x is bigger than 6. So notice they repel each other, so we can see an or statement. And it should match that or up there. Let's do one more example over here. Okay, so again we have 2 problems. Do this one here. So I'm going to subtract 1 from both sides. 3n compared to negative 6 divided by 3 n is equal to negative 2. Now don't say, well, I got a negative. You did not multiply or divide by negative, so nothing changed, so the sign stays the same. Same thing over here. We're going to add a 5 to both sides, and we have 2n compared to 12 divided by 2, and n compared to 6, and again multiply divide by negative, did not, so the sign stays the same. So I always like to start with the numbers. Negative 2 goes obviously to the left of 6, and then we have open circles. Now again, let's look at the arrows here. So we have n is less than negative 2, and an n is bigger than 6, so they're going to repel each other, and again we can see the or statement. So there's good examples of and or statements. Alright, so what I want you to do is try these examples. First identify, is it an and or an or, depending on what you see. And then here we have, I want you to translate them to a number line, what it would look like. So let's go ahead and try that.